Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to thermodynamics, and in this video we are going to discuss very in a very quick and short manner. We'll discuss the gas laws because we will be discussing this in detail in the discussion related to kinetic theory of gases. But why I'm giving you just a basic idea of this, because in the upcoming videos some terms will come which will have some direct or indirect connection with the gas law. So just have a basic idea right now, then when we'll go to kinetic theory of gases, there we'll be discussing it in detail. This is just a quick basic concept. So like I said in the first video related to heat and temperature, in order to specify a system, in our discussion on thermodynamics, whenever we talk about a thermodynamic system, any object, whatever it is, the discussion will be on the basis of three main parameters, three main properties of that object, that system. First, there is no specific order, these three are equally important, but first pressure, then temperature, and third volume. Okay, and we will always try to establish a relationship that will connect these three thermodynamic parameters. Okay, so what is that relationship? All that will come to know in the kinetic theory of gases and in the discussion related to thermodynamics and in the upcoming videos. Here we will be discussing some laws which are related to basically the gas laws, the molecular movement of gases, and how pressure, temperature and volume, they are interrelated. It is given by these gas laws. So they are Boyle's law, Charles' law and Gay-Lussac's law. So we'll be discussing them one by one in a very quick way. So first one is Boyle's law. So Boyle's law, it gives us the relationship between volume and pressure of a gas at constant temperature. Okay, so it states, the statement of Boyle's law is that if temperature is remaining constant, it is kept constant, the volume of a given mass of gas is inversely proportional to its pressure. Okay, if temperature is constant, volume of a given mass of gas is inversely proportional to its pressure. That is, if pressure is increased, its volume will decrease, and if pressure is decreased, then volume will increase. Inverse relationship. Okay, volume is inversely proportional to pressure. V is directly proportional to 1 by P, or we can say V is equal to K by P, where K is the proportionality constant, or PV is equal to K. So here is the important relationship. Let us say we have two thermodynamic states. At constant temperature, temperature is kept constant. Let's say in state 1, pressure is P1 and volume is V1. And in state 2, we have pressure is P2 and volume is V2. Temperature is constant. So, according to Boyle's law, P1 V1 is equal to P2 V2. That is, the product of pressure and volume, it will always be constant. Okay, for any thermodynamic state at constant temperature, the product of the respective pressure and volume in that state, that will always be constant as per Boyle's law. So graphically we can represent it as this. Okay, this will be the curve. Okay, so as volume increases, pressure is decreasing. Okay, and as volume decreases, pressure is increasing. At low volume, pressure is high. At low pressure, volume is high. Okay, constant temperature. And if we plot this, on one side we take pressure and in the other we take 1 by V, or we do the opposite. We take 1 by P and V. In both the cases we will have a straight line passing through the origin with a certain slope. Again, temperature should be constant. Okay, so this is Boyle's law. We can simply remember it as volume is inversely proportional to pressure at constant temperature. Next is Charles' law. Okay, again I missed one thing. It was given by Robert Boyle, this law. Okay, it was given by Robert Boyle. Then Charles' law. This is again another fundamental gas law, and it gives the relationship between volume and temperature at constant pressure for a gas. Previously it was volume and pressure at constant temperature. Here volume and temperature at constant pressure. It was given by Alexander Charles. So just try to understand this statement first. Okay, the statement of Charles' law, it says that if the pressure is kept constant or it remains constant, then the volume of a given mass of a gas increases or decreases by 1 by 273.15 of its volume at 0 degree Celsius for each 1 degree Celsius rise or fall of temperature. Okay, so here if you remember, this 273.15, this is the ice point temperature, 0 degree Celsius or 273.15 Kelvin. They are the same thing. They are the same thing. So what it says, that if pressure is kept constant, then the volume of a given mass of gas, it increases or decreases by 273.15 of its volume at 0 degree Celsius. Let's say the volume at 0 degree Celsius, that is equal to V0. It is the volume at 0 degree Celsius. Then at T equals to 1 degree Celsius. Okay, this is T equals to 0 degree Celsius. At T equals to 1 degree Celsius, V1 is equal to V0 plus 1 by 273.15 into V0. Okay, V0 plus V0 by 273.15. This is the volume at temperature 1 degree Celsius. Then at T equals to 2 degree Celsius, V2 is equal to V0 plus 2 V0 by 273.15. Okay, which is equal to V0 into 1 plus 2 by 273.15. Similarly, it will go on. So in general, at T degrees Celsius, volume at that temperature, that is equal to V0 plus V0 T by 273.15, which is equal to V0 into 1 plus T by 273.15. So, at every 1 degree Celsius change, there is either an increase or decrease by 1 by 273.15 into its volume at 0 degree Celsius. Here there is a change of 2 degree Celsius. So, 2 V0 by 273.15. Similarly, at T equals to 3 degree Celsius, it will be V0 plus 3 V0 by 273.15. So, likewise it will go on and on and on. And for negative temperatures, this plus will become minus. It will become minus. So, at minus 1 degree, it will be V0 minus V0 by 273.15. It will be V0 minus 2 V0 by 273.15, like that. Okay. So, this is the thing with Charles' law. Here, this is represented in that way. This is the general statement. The volume of a gas at T degree Celsius is equal to V0 plus V0T by 273.15. So, here this is the important thing to understand. This V0 by 273.15, that is multiplied with T, the temperature at which we want to determine the volume, that is added with this volume at 0 degree Celsius. And again here 273.15 plus T degree Celsius, that is the temperature in Kelvin. Okay. So, if you have to convert Celsius to Kelvin, simply we add 273.15. So, here this volume Vt can be written as V0 capital T by capital T subscript O, where these temperatures are in Kelvin. So, in terms of Kelvin, we can write it directly as Vt is equal to V0 into this whole thing. This is equal to temperature in Kelvin T, and this is the temperature at 0 degree Celsius in Kelvin. Okay, 273.15. So, this becomes V0 into T by T0. So, we can see in terms of Kelvin, only in terms of Kelvin, this is very important. Only when the temperatures are expressed in Kelvin, the volume at that given temperature is directly proportional to that temperature. Okay, it is directly proportional only in terms of Kelvin. Okay, in general also we can say, but it is easier to convert it directly into Kelvin, because there will always be, if we express it in Celsius, there will always be an offset, some constant, either the graph will start a little bit above or below. When we express it in Kelvin, it will directly, it will start from the origin like that. So, that is why it is always better to express it in Kelvin. So, in terms of Kelvin, volume is directly proportional to temperature when expressed in Kelvin, that. Okay. So, we can alternately express Charles' law that pressure remaining constant, the volume of a given mass of gas is directly proportional to its absolute temperature. Okay. So, this is Charles' law. Volume is directly proportional to temperature, pressure remaining constant. Okay. So, the graphically we can express it as this: temperature expressed in Kelvin, volume is directly proportional to temperature. It is a straight line with a certain slope starting from the origin. Okay. So, this is Charles' law. Then Gay-Lussac's law. So this law, it gives the relationship between pressure and temperature of a gas at constant volume. So here volume is remaining constant, we have to establish a relationship between pressure and temperature. It was discovered by Joseph Gay-Lussac. So it is, in a way it is similar to Charles' law in its statement, but only the variables are interchanged. Here it says that if volume remains constant, the pressure of a given mass of gas increases or decreases by 1 by 273.15 of its pressure at 0 degrees Celsius for every 1 degree Celsius rise or fall of temperature. It is very much similar to the statement of Charles' law, only here it says, here pressure is constant in Charles' law, here volume is constant. Okay, so here the pressure of a given mass of gas, it increases or decreases by 1 by 273.15 of its pressure at 0 degrees Celsius. So we can express it in this way. Okay, same principle like I have done it here. Here instead of V we will substitute P, that is pressure. Okay, everything else is the same, in the same manner. So this is the expression. Pressure of a gas at a particular temperature T expressed in Celsius is given by Pt is equal to P subscript 0, which is the pressure at 0 degrees Celsius. P0 is the pressure of the gas at T equals to 0 degree Celsius plus 1 by 273.15 into P0. Here this 1 by 273.15 into P0, that multiplied with T, that is the temperature, specific temperature expressed in Celsius. So it is given by P0 into 1 plus small t by 273.15, again 273.15 plus T is degree Celsius, that gives us the temperature in Kelvin, and this is the temperature at 0 degree Celsius expressed in Kelvin. So this becomes Pt is equal to P0 capital T by capital T0. Okay, this is all expressed in Kelvin. Okay, so here pressure is directly proportional to temperature in terms of Kelvin. Okay, when expressed in terms of Kelvin. Okay, so Gay-Lussac's law can be alternatively expressed as volume remaining constant, or the volume of a given mass of gas remaining constant, the pressure is directly proportional to its absolute temperature. Okay, volume remaining constant. Okay, and here graphically it can be expressed as this: temperature in Kelvin, this is the pressure, it's a straight line with a certain slope, okay, and volume is constant passing through the origin. Okay, so here I have just expressed, given some basic idea related to gas laws. We will be discussing them in detail in kinetic theory of gases in that discussion. So don't worry about it. I have just had this discussion because in the upcoming videos we will be coming across several terminologies, several concepts where there will be some indirect or direct reference to gas law. So when there I will say according to Charles' law, according to Boyle's law, according to Gay-Lussac's law, I will give some reference. You will be it will be easier for you to grasp it. Okay, so this is it. So these are the three basic gas laws. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.